Let's talk about the N-ary preorder traversal. So you are given a root and then return a preorder traversal of its value. So let's look at the example. So you are at a root, right? And then the preorder is going to be you, and then you go on your child, and then you go on your child, and then you go on your your child, and then you go on child, and then there's a no. You come back to your right child, and then later on you come back, and then come back, something like this, right? So you will print out this. So the idea is that you print your current node value, and then go left, and then go right. So this is the entire solution. Like print your current node value, and go left, then go right. Alright, so this is pretty much it. But the problem is what? We are using another format because there's a children, which is a list of node. So we can just traverse the list of node, which is children, right? We just traverse the children. We don't need to think about like left or right. We just traverse the children because the children is from left to right. And let's talk about the first solution is using a recursion. So I'm going to just say recursion. So we need to return a list of integer, right? List of integer is going to be a result, new array list. I will have to return result. Alright, so now I need to create a helper function, and my helper function is going to be public void get preorder traversal list, something like this, right? And then I need to pass in the list of integer result. I'm going to pass in the current value, no. And let me just move my windows. So I need to get this. I need to put my result. I need to put my root into the function. Alright, so the base case is going to be what? If the node is actually null, I will return. So if a node is not null, which is the list, right? I will have to, if a node is not null, which is going to be what? At the bottom of the tree node, it should be a leaf, right? Then you need to what? You need to just print your current node value. So it's going to be result.add node.val, and then you want to go left and go right. But in this question, we are using the children, so just traverse children. So how do you traverse? Flow child, child children. And how do you get the children? It should be node.children, right? And then again, how do you go? You basically just call the function. So result child. So this is the entire solution for recursion. So let me run it and submit. Alright, so I pass the test, right? Accept. So the next solution is going to be what? Iterator, right? So how do you do this? Let me just use the example one. So I need to create a list of integer as well. So which is the result. I also need to create a stack. So stack is pretty helpful because I need to traverse my children. So how do I traverse my children? From left to right, right? But the problem is what? The stack is first in, last out, right? So I can push my stack from the last child to the first child. So in this case, 4, 2, 3. So when I pull my child, right? I pull this out, and then I can what? Check, do I have a children or not? If I do, I need to push into the stack. So child for the node 3 has what? 5 and 6. Again, I need to put my child value from the back to the front. So this is out. So I push 6 and 5. Okay, so now the first one, I mean, we definitely have the result, right? So I put 1, I put 3 because I pull, right? Now again, I pull what? I pull 5. I pull 5 out. Does my 5 have children? No. Okay, I add. Then I delete. I pull my 6. Does my 6 a child? No. I push. Alright, now I come back to the 2, which is the another children of root, right? So I pull 2 out. Does my 2 have a child? No. 2 and 4. So this is pretty much it, right? So again, this shouldn't be hard. So iterator is going to be what, list of. So the idea is pretty similar. List of integer result. Do a new array list. I can check is my current root is actually no. If not, then return the result. Else, return the result. And I need to create a stack. No. And I'm going to call stack new stack. So if the no, if the root is not null, I can just push my root. Alright, so now I need to see. I need to traverse, right? So I can say, well, the stack is not empty. I can keep traversing, and I need to pull my stack, the top one, so pop. So I would have to add my current value, no.val, into the result, and traverse from the back, from the end to the front, right? So it's going to be I equal to what? No.child, I mean children, dot size -1, I greater or equal to 0, I minus max. Right, and so this should be the what? This should be the last child, right? It should be the last child. So how do I get it? No.children.get AI, and then once you finish, then you will just what? Go on your next value for the stack, and then keep going until the stack is empty. So this should be the answer. So let me run it. And accept, right? So I submit. So accept, right? So I will have to make a what? I'll have to make the breakpoint just in case you didn't follow up. So the breakpoint is going to be this one, all right? And starting. So yes, so I will just keep going, and you will pause at any second, and alright, I know this is the this is the address, but it doesn't matter. Like when you look at the value in the result array list, then you'll be able to find out what happened, right? So this is pretty much a solution. So let's talk about the time complexity and space complexity for iteration. So the space is going to be all of n, and the time is going to be all of n, right? It's going to be like traverse every single one of it in the tree, right? And then for the recursion, this is the recursion solution. The space is going to be all of n, and the time is going to be all of n, right? You're still traversing every single one of them, and then add into the list of integer, right? So the time and space are the same, and then n represent the number of the node in the tree. So this is my solution, and I will see you next time. Bye.